In this video, we are going to do a quick review of our multiplication and division properties of exponents. So the first one here, go ahead and title Review of Exponents Part 2, Multiplication and Division Properties. And our first property is the multiplication property. So I want you to write it out in words to start. To multiply powers with the same base, keep the base, and add the exponents. So remember here that multiplication and addition go together. Multiplication and addition go together. So the property itself says that if you have a to the m times a to the n, that is going to be keep the base and add the exponents, m plus n. And we're going to do a couple of examples. Our first example, I'm just pausing for a second to give you time to catch up. Pause if you need to. Our first example here, I've got 2 to the third times 2. Remember, there's a little invisible 1 here. 2 to the 1. Since I have the same base and I am multiplying, I keep the base and I add the exponents. Now I can leave it just like that, or if I'm able to evaluate, I can. 2 times 2 is 4, times 2 is 8, times 2 is 16. Looking at example 2, this time I have 3 x's, x to the 5th, x to the negative 2, and x to the 4th. That doesn't change anything. I'm still going to keep the base and add the exponents. So I'm going to do, and normally I don't write this, but I'm going to write it here just to make sure we all understand. I'm going to do 5 plus a negative 2 plus 4, which is going to be 3 plus 4, which is going to be 7. Pause if you need to get any part of that, and then we're going to go to our division property. So our division property, again, I want you to write it. Our division property says to divide powers with the same base, keep the base, and subtract the exponents. So division and subtraction go together. Division and subtraction go together. The property itself says that if I have a to the m over a to the n, I'm going to keep the base and I am going to subtract my exponents. Now this one can get a little tricky, especially keeping in mind that we usually want to write our exponents with a positive exponent, not a negative one. So we're going to always want to try and pay attention to where the higher exponent is, whether it's in the numerator or the denominator. Or we could just always bring it all up to the numerator, and then if it's a negative exponent, drop it back down. So we're going to do a couple of examples. I think a total of 3. Here's our example 1. So I have the same base. The base is 3. Notice that my highest exponent is the 10, and the 10 is in the numerator, so I'm going to keep it in the numerator. And as my computer catches up to me here, there we go. Computer was going slow. Let's go back to it. So I'm going to keep that 3 in the numerator, and then again, I don't typically write this one, but I'm going to subtract my exponents. Now 3 to the 6th is actually a pretty big number, so I'm just going to leave it right there at 3 to the 6th. I could evaluate that if I wanted to. Let's do example 2. So again, this time remember that x has a little invisible 1 on it. If there is a variable with no exponent, the exponent is understood to be a 1. And again, I want to take a look at where my higher exponent is. And in this case, that higher exponent is the 1. So when I do this, my x is going to stay in the numerator. Let me try that again. My x is going to stay in the numerator, and I'm going to do 1 minus a negative 4. Be super careful there. That minus a negative is going to become plus a positive. So that's going to be x to the 5th. And then our final example, example 3. I'm going to do this one two different ways. First, I am going to say my -5 is the higher exponent. -5 is bigger than -10. So when I do this one, my y is going to stay in the denominator. I'm going to need a 1 to hold my spot. And I'm going to do -5 minus a -10. I am dividing, so I subtract my exponents. That minus a negative becomes plus a positive. So -5 plus 10 is +5. So I could get y 1 over y to the 5th. Let me show you your second option, just so you can see that I'm going to get the same answer here. So if I went ahead and brought it to the numerator, I would do -10 minus a -5. That minus a negative would still become plus a positive. -10 plus 5 is -5. And my negative exponent property would drop me to the denominator. So you can either do like I did here and think about where the larger one is to begin with and keep it there, do the subtraction from there, or you can always just bring everything up to the numerator and then take care of your negative exponents. Again, I'm going to give you the whole page here. Pause if you need to catch any part of this. And that is it for our multiplication and division properties.